Welcome to iOS Insights. This is the first part of the Tic-Tac-Toe, also known as Noughts and Crosses tutorial. The game will be designed using MVVM, SwiftUI and Swift. We will now start the tutorial. Continuing from last week, enter into the game view model file and then on line 40 type the following: else if check draw open bracket close bracket. And now we need to implement the check draw function. So just type in func check draw. Oh yeah, also make it private. And then the next thing we need to do is it needs to return a Boolean variable. And then type in for row in 0 dot dot less than board size. Just make the screen a little bit larger. For column in 0 dot dot less than board size, if board open bracket row open bracket column close bracket, and this variable should be called column, equals nil, return false. So what this line does is that if there is an empty cell on the board, return false, indicating the game is not a draw. And then on line 53, just type in return true. And what this does, it just checks if all cells on the board are filled. Return true, indicating a draw. So that should be true. And now the next thing we need to do is, oh yeah, we can add the reset game functionality. So just type in func reset game. That should be private. Private func reset game. Board equals array open bracket repeating array open bracket repeating nil, count is 3 and double count is 3. So what this does, it resets the game board by creating a new two-dimensional array with all the cells set to nil. And now type in current player equals naught. So navigate back to line 42, I think it is, or 40. I made a mistake. So what this should be, we need to delete all of line 40, just this section here, and also delete this one here. And now we type in a bracket, and then, is that correct? Just trying to work it out. Type in a bracket, and else if check draw open bracket, then type in dispatch queue main async, and let's type in self show alert, or just copy this line from line 36, type this in, paste it here, and then for the message you can just type in it's a draw, type in it's a draw, and then on line 43 type another else statement. If current player is equals dot cross open bracket, so if the current player is crosses, then call the make the computer move. So just type in the actual function. It's not been defined yet, but type it in. We'll define it in a minute. Make computer move. So the make computer move function we will define on line 50. So just type in func make computer move if let winning move is equal to find winning move open bracket player dot cross. So we have to create another function that's undefined at the moment. So the name of the new function is called find winning move. So we'll just create it on line 50. So just type in func, or private func should be really, private func find winning move open bracket player open bracket row int column int. So what that line does defines a function find winning move that takes the player as a parameter of type player and returns an optional tuple of type row, int, column and int. So tuple, something a little bit similar to a struct, so you can have like properties, it can return more than one value, tiny bit similar to an array. So now that we've created the actual function signature for find winning move, we can continue with the make computer move function that we started. So on line 55, just type in the brackets and now type in make move open bracket row winning move dot row column winning column winning move dot column winning move dot column, and then just type in return. So what this line does is check if the computer can make a winning move, placing 3 crosses in a row, a column or diagonal. If a winning move is found, make that move by calling the move method and return from the function. So next what we need to do is check for blocking moves. So just type in if let blocking move equal to find winning move player.naught make move blocking move dot row blocking move dot column, and then type in return. So what that does, it checks if the computer needs to block the player from making a winning move, placing 3 noughts in a row, column or diagonal. If a blocking move is found, it just makes sure that the caller that's making the move from that function cannot position the actual like noughts or crosses in that section. So the next thing we need to do now is type in var available spots int open bracket close bracket. So what that does, it just choose a random spot from the available spots that the player or the computer can use to make their move. Now type in for row in 0 ... is less than board size for column in 0 dot dot is less than board size, if board open bracket row open bracket column there should be a bracket here. If it's equal to nil, available spots dot append row and then column. So what this does, it iterates through the board to find all available spots. Cells with a value of nil, stores the coordinates of the available spot in the available spots array. And then within this function, the final thing we have to type in is if let random spot is equal to available spot dot random element make move random spot 0, and this is a tuple, random spot dot 1. So what this does, if there are available spots, choose a random spot from the available spot array, and then it makes the move by calling the make move method with the chosen spot, row and column. So which one was this one? Move. So now type in if count equals board size minus 1, let row equals empty row, return open bracket row column. And what this does, if the count of cells occupied by the player is equal to the board size minus 1, one empty cell and there is an empty row available, it returns the row and the column as a tuple representing the winning move. And now what we do is we just type in, just checking, yeah, just type in var count equals 0, var empty row empty row, that needs to be an optional int, empty row colon int question mark, var empty column which is an optional int, and then just type in for I in 0 dot dot is less than board size, open bracket, if board open bracket I close bracket open bracket I close bracket is equal to player, and then count plus equals 1, else if board open bracket I open bracket I is equal to nil, empty row is equal to I, empty column is equal to I. And now what we do is we just type in the following, which is count no, we don't type in count, it's a mistake. We need to, I think we have to use a tuple, I think. Just checking. Yeah, so what we need to do is just type in the count. Just checking to see. Just type in, so it's if count equals board size minus 1, let row equals empty row, let column equals empty column, return row and then return column within the tuple. So what this does, if the count of the cells occupied by the player is equal to the board size minus 1, one empty cell, and there is an empty row and column available. Return the row and column as a tuple representing the winning move. And now we just type in count equals 0, empty row equals nil. Empty column equals nil. For I in 0 dot dot is less than board size, if board open bracket I close bracket open bracket board size, so we're navigating through the two-dimensional array, minus 1 I is equal to player, and count plus equals to 1, else if board open bracket I close bracket open bracket board size minus 1 minus I is equal to nil, empty row is equal to I, and empty column is equal to board size minus 1 minus I. So what that loop does, it goes through the secondary diagonals and counts the number of cells occupied by the given player. It also keeps track of an empty row and column in case there is a potential winning move. So the next thing we need to do, it's nearly at the end now, just type in if count is equal to board size minus 1, let row equals empty row, let column equals empty column, and then return the row and the column. So if the count of cells occupied by the player is equal to the board size minus 1, one empty cell, and there is an empty row and column available, return the row and column as a tuple representing the winning move. So finally we return a nil. So what the nil means is that if no winning move is found, return nil to indicate no winning move is found, as in available, it wasn't there, no one won. So now we'll run the application to see if it works. Okay, so I'm noughts, and the computer hasn't made a move as yet, So it seems like we missed something out. It must be in the make move function. So let's go back to the make move function, because the computer should have applied this X somewhere in the actual grid. So let's go back to the make move function and see if we can fix that. Make move, so where's, I think it's on line 32. Or would it be here? Yeah, I think it would be here. Yeah, we missed it out. So type in current player is equal to open bracket current player equals double equals, I mean, dot naught question mark dot cross colon dot naught. So let's run it now and see if it works. Okay, so I'll go again. Yeah, this time the computer is working. I'm noughts, the computer is crosses. So I'll place my naught here. Oh, so the computer won that time, as you can see. But at the moment it's not calculating the scores. So we'll just do that now. So to display the actual score, just go back to your content view that we done last week. And then within your content view, navigate to line 46. Yeah, about 46. And then we get the computer score from the view model, and the same applies with the person score. We get it from the view model as well and display it into the text box. So all we have to do is just type in the following: view model dot computer wins, and that shows the amount of times the computer has won. That's what that does. Oh yeah, we need the comma there at the end and a comma at the beginning. And we do the same thing for the player. So I just copy that line. And then we replace that line there. Didn't copy it. Just replace that line there. And then we just type in player wins. Player wins. And now when we run the application, we should see the scores being incremented when there's a winner. So let's run it now. So I'm noughts, the computer is crosses. But this time I won. So the score is 1-0. So let's play again. So to play again, you can click on the reset button Did we do the... Oh yeah, we haven't added the functionality for the reset button. We added the actual view model functionality, but it's not being called from the view. So to do that, navigate to the reset button on page 69. I mean on line 69. Line 64, I mean. No, 7, line 67. And then just type in view model dot reset game, and now run it again. It's just compiling, and oh, it failed. So why doesn't it work? Let's see. So why is that not working? Let me try it again. Oh, that one's not working. Maybe set to private. Oh, that should be public. That's why it's not working. So set to public now. It will work. Just compiling at the moment. This time I will allow the computer to win. So just place the naught there, some noughts. See, the computer won. And now to reset the game, just click on the reset button. And then the game is reset. We have now reached the end of the tutorial. I hope you enjoyed it. All the source code is downloadable from iosinsights.co.uk. To get all our notifications, please comment, like and subscribe. And this helps you to keep up to date with the videos as well. See you next week.